Algebra 2, Cram. New York State Algebra 2, Regents. Common Core, basic graphs of trigonometric functions, range of cotangent x. Concept number 8. The odds of someone doing exactly what I tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. So inbox me at memedicine@gmail.com for ordering and pricing instructions. Be sure to spread the word to your friends and classmates who also need to cram. They too can inbox me at memedicine@gmail.com. If this isn't the subject you're looking for, no worries. Still inbox me at memedicine@gmail.com for pricing and ordering on personalized packages. All right, let's cram through the range of the cotangent of x. Basic graphs of trigonometric functions. Range of cotangent x. Before we delve into the concept, I want you to recall a few things regarding the cotangent of x. And here in this introductory concept, we're going to use the variable theta to represent the angle instead of x, because we have x denoting the x coordinate here. We don't want to double up on variables. So here we see a Cartesian coordinate plane, our xy plane. And we see in quadrant 1 that we have drawn in an acute angle. The vertex is at 0, the origin. The initial side ray ending at the x-coordinate is on the positive x-axis, and the terminal side ray ending at the y-coordinate with a magnitude of r, the measure of like what looks like could be a radius. It terminates in quadrant 1, so therefore it's an acute angle. An acute angle has a measurement between 0 degrees and the quadrantal angle 90 degrees. Okay, this particular acute angle is a reference angle. Reference angles have their initial side again on the x-axis, and they terminate within quadrant 1. Okay, so if you were to do a horizontal flip across into quadrant 2, this reference angle would still be an acute angle. However, you would have some sort of optical illusion, because the angle that you would really be referring to is the obtuse angle that traverses but ends at what appears to be a flipped version of this acute reference angle. So it's important for you to note that when your calculator is calculating trigonometric functions such as cotangent, tangent, cosine, or sine, it's actually calculating values for the reference angle, and you would have to specify obtuse angles in other quadrants. Let me demonstrate what I mean by this. Let's say this angle is equivalent to 40 degrees. Well, let's say you were to go to the extent of 40 degrees here. What you would really be looking at is an angle of 180 minus 40 degrees. And please hold on, my phone is ringing. Okay, now where were we? Yeah, so if this acute angle is 40 degrees and you were to go flip it over here, you would wind up at this extent, something that looks like this. Sorry for the non-scale drawing. Yeah, so basically, that this is theta. What you would really be interested is in this, and that is going to be 180 degrees minus 40 degrees. So that would be 140 degrees. So if you have your reference angle in quadrant 2, it's basically going to be 180 minus the reference angle. In quadrant 3, it's going to be 180 plus the reference angle. And in quadrant 4, it's going to be 360 minus the reference angle. Okay, so that's just a little bit of convention for you. All right. Okay. So, yeah, we've checked off the concept of our reference angle. Yeah, now we need to discuss the actual cotangent. The cotangent theta is the cofunction to the tangent theta, and the tangent of theta is basically equivalent to y over x, or the sine over cosine, Or you could say, pretend that's an x equal y over x, or the opposite side over the adjacent side. Well, the cotangent is just basically the reciprocal of tangent, or its cofunction, and when you multiply the cotangent or and tangent of a specific angle, you should get 1, okay? All right. So basically, yeah. So if this is theta, your cotangent is going to be the adjacent side divided by the opposite side. And here on our Cartesian coordinate plane, we can have an adjacent side that's negative and positive. Negative in the case that the x-coordinate is on the negative x-axis in quadrants 2 and 4. And we could also, 2 and 3, and we could also have a negative y value in the denominator in the case where the opposite side, or the y coordinate, is in quadrants 3 and 4. Okay, so just keep that in mind. Double negatives is going to give you a positive cotangent, but if either x or y coordinate is negative, it's going to give you a negative cotangent. And just remember, for basic trigonometric functions like sine and cosine, you are having to look at r in the denominator, and r is a magnitude. It's the measurement of the longest side or hypotenuse, so that's always going to be positive, because a magnitude is a measurement, and it's like a distance formula that you have to use to calculate this. So distance formulas are always square, therefore you're always going to have a positive answer for that. Okay, so that's just to orient you really quickly. So what is the range? And when I say range, I mean, what is the set of all possible values of a dependent variable, usually expressed as y, of the function y is equivalent to the cotangent of x, or theta. So definitely press pause again, and I'll give you a moment to think. Draw a graph to express your answer and your reasoning, okay? All right, so okay, so hopefully by now you were able to press pause and come up with a solution, and if not, that's completely fine. So here we have the graph of y is equivalent to the cotangent of x. And you see that here on the x-axis, or the horizontal axis, you have pi radian measures, okay, in increments of pi over 2, which equates to 90 degrees. So pi over 2, 90 degrees, pi 180 degrees, 270 degrees, and so forth, okay? And the same, but negative in the negative infinity or negative x direction. So here the range, which is again the set of all possible dependent variables, is basically going to be determined by finding it. You have to do a visual inspection first and find wherever the y values exist, okay? And you can kind of see that, well, if you watch the Cram session on what the domain of the cotangent of x is, you would have found out that the domain is all real numbers except whole number multiples of pi, because pi yields a 0 in the denominator for the y value, because it, at like values like 180 or 360, there's no y coordinate, so that's going to be 0, and that 0 is in the denominator, therefore the fraction would be undefined, and hence you get indefinition and vertical asymptotes, all that good stuff. But that's not the case with the range. And the answer is all real numbers, okay? Because regardless of these vertical asymptotes, you're still going forever upward in the positive infinity direction and forever downward in the negative infinity direction, okay? And because this function is a function because it passes the vertical line test. However, it's not a one-to-one function because it doesn't pass the horizontal line test, meaning that for every element in the domain, there isn't only one element in the range, okay? Because as you can see here, several x or independent variables can have the same answer of -2. Okay, so it's not a one-to-one function, although it is a legit function. And just in case you're wondering, like, what the heck is a real number? Real numbers include rational and irrational numbers as well as integers. When I say integers, I mean like counting numbers, like 0, -2, and 1. All the regular numbers you would find like on the number line, okay? And irrational numbers can be expressed as a over b in fractional form, where b is not equal to 0, but it can be equal to 1. So some examples of like a rational number, or one example, just to save time, would be 2 over 1, or even 1 over 2. And when you convert a rational fraction to a decimal, the decimal either terminates or repeats. 0.666, I think that's like 2/3, that's a rational number. However, irrational numbers can't be expressed as a over b, where b is not equal to 0, because when you convert that fraction to a decimal, the decimal continues on forever. And an example of an irrational number, let's show you, would be the square root of 2 over 1. Okay, so that's an irrational number, and the reason why is, first of all, when you ignore the denominator, but when you try to take the square root of -2, you're going to get something. I only memorized a few places out beyond the decimal. For this, it's going to be like 1.41. 42, I'm not going to write the rest because the lag time is just too long. 1356 ... Okay, and so yeah, like if you have this number over 1, that's gonna look weird. That's irrational. Same thing for pi, the numeral pi, not pi as a radian measure. Okay, all right, so that's like a full recap of all the good stuff. We went over rational, irrational numbers, the range of the cotangent of x, even a little bit on the domain of the cotangent of x, what the cotangent is, quadrants 1, 2, 3, 4, acute angles, reference angles. We crammed all that stuff in here, and I know it's like been over 10 minutes, but so what? Play this on double speed and definitely order the complete cram session. All right, have a great day.